Right, we saw how to migrate from 4 to 6. Two simple methods. One is dual stack, the other one is the 6 to 4 tunnels. Initially, we'll just take two routers and do dual stack. Not really that big lab, but this is going to be the best solution in the industry. Not going to be, it is already a best solution in the industry. Dual stack, having IPv4 and IPv6 together. So ISP is going to provide us both IPv4 and IPv6 services. Now the truth is they do provide even today both 4 and 6. If you speak from 6 address, you get a response. If you speak from 4 address, then also you will get a response. Because you may have some customer in IPv4. You may have some customer in IPv6. As an enterprises, you will be talking to various customers. Not everyone is migrated to 6. So we need to talk to both. We cannot just change ourselves to IPv6 and deny service to IPv4 customers. Not really fair. So you need dual stack. So here we got IPv4. Just as an example, this is not really a lab that to be done and then, but still, for satisfaction, because this is important migration method. Even without doing, when I explain, you might have understood. But because it is widely used now and found us a best solution, I want to do it. You see, I'm going to run OSPF and form neighbor IPv4 neighbor first. And now, after I finish IPv4, when I'm able to ping from 1111 to 2222 without interrupting, without disturbing IPv4, we will also have IPv6. There won't be any downtime for IPv4. Let me have BGP instead of OSPF. So you see interface F00. Now share the IP address 102.102.102.1 255.252. Interface loopback 0 IP address is 101.1.255. We are going to have BGP router BGP autonomous system as 12, and I'm going to say neighbor is 102.102.102.2, remote AS is 12, and I want to advertise this IPv4 address. Oh my god, I should have typed mask. What is my strength? Okay. Now I have BGP configured and I also advertised the network. Let me also do the same on another route. Oh, I made mistake. Instead of configuring on router 1, I have configured on router 2. It's okay. We can simply swap this one here, this one here, this one here, and this one here. Nothing wrong. Okay, whatever I have configured here, show IP interface brief. If you see, this is matching on router 2, and this is matching on router 2. Right, so it's okay. Now let us move on to router 1. On router 1, I'm going to say interface loopback 0. IP address is 2.2.2.2. Interface F00. IP address is 102.102.102. Alright, what is next? Router BGP 12. Neighbor is 102.1. Remote AS is also 12. Network is 2.2.2.2. Mask. Right, I would expect now a route. Let's see. Show IP route BGP. Wow, we got a route. You see, you got running BGP with under IPv4 source. Repeat one whatever. It's pinging, pinging, pinging. Keep on pinging. As it is pinging, I'm going to enable OSP. Sorry, I should enable telnet. It's okay. Let it finish pinging. Meanwhile, I'll go to router 2 and configure IPv6. Router 2's loopback is going to have 1111:1111/128. And on R1 loopback, I would like to give 2222:2222/128. And on the physical interface, I would like to assign 2000:1/64. It's okay, you can also give 32, but practically speaking, only ISPs of ISP, like my friends company Gilab in Kanarti, only they can have that 32 because they are ISPs of ISP. Not possible for us to have that as an customer. Okay. Now we got this IP addresses. For the IPv6 configuration, if you notice here, in router 2, I have finished configuring. Say show IPv6 interface brief. You have IP address on the IPv4 show command, but not in the IPv6. Same interface F00. If you see show IP interface brief, you have an IP address. Now I would like to put IPv6 address so that here I can see some address like this. Interface F00, IPv6 address 2000:2/64. That's it. The interface is already up. The interface loopback 0 IPv6 address 1111:1111/128. Then, if you now notice, show IP interface brief. You have F00, it's IPv4 address, and F loopback with loopback 1111. The same command, sorry, same interface for IPv6. It has got this, which means dual stack, same interface. I've got both 6 and 4. And you can see that in the running configuration very well. Show run interface loopback 0. You can see both IPv4 and IPv6 coexist. Likewise, interface F00. You have both the address coexisting. Now let's move on to router 1 and verify the same. The ping is still going on. Okay. I think I gave a very big number. No problem. Meanwhile, I'll finish BGP configuration. You see, the ping is going on. I'm saying router BGP. Same number 12 only. You should not use any other autonomous system. And as usual, you will say neighbor, but this time it's going to be 2000::1. Remote AS is going to be 12. Address family IPv6 unique guest. Okay, IPv6 needs to be enabled first. So in the global configuration mode, you say IPv6 unique guest routing. Now you go back to BGP and say IPv6 unique guest routing. And then activate the neighbor which you say. Neighbor, see earlier I have said neighbor as what? 2000::1 that I need to activate. Activate, that's all. Okay, so that's all. There is no disturbance cost to the ping that is happening. All right, we have enabled BGP with IP address. I'm waiting for this ping to get over so that I'll start pinging from router 2 and enable BGP on router 1 to show you there won't be any packet loss when BGP comes up. When IPv6 BGP comes up, IPv4 will not get disturbed in any manner. Now, we will ping from router 2, ping to source 11111, maybe 10,000, 1, 2, 3, 4. Oh, repeat. Not rapid, repeat. Okay. What? So, yep. So the convergence. So it's repeating, it's pinging, and we have already configured on router 2 IPv6 BGP. Now I am on R1 to configure IPv4. Sorry, IPv6 BGP. Show IP. Show run interface F00. If you see here, we already got IPv6. Oh no. IPv6 address 2000::1 /64. I'm in the wrong place. Interface F00. And then interface loopback 0. IPv6 address 2222::2222 /128. See, I have assigned the IP address and there is no disturbance cost so far. It's pinging. I'm going to run BGP also, router BGP 12. Neighbor is 2000::2. Remote AS is 12. And then network, I would like to advertise is 2222::222 /128. Sorry, the network of IPv6 should go under address family. See, the neighbor has already come. The neighbor has already come, and you see there is no disturbance cost to the ping. There is no packet loss. So migrating to IPv6 is best, if you use this method dual stack, just from the IPv6 unicast. You need to activate, though the neighbor has come, it's a good practice. The neighbor has come because one side you have enabled. It is a TCP based protocol, so as soon as the reply comes, the neighbor has come up. But it is a good practice to, not good practice, it's mandatory to put the activation command. You see the ping is still going on, and let me advertise. Network command will come under address family. 2222:2222/128. All right. Likewise, I would like to advertise router BGP 12 net address family IPv4, sorry, IPv6, unicast, neighbor 2002:2, activate. I think we already did this. I need to say network. I think I'm in a wrong mode, that's why. IPv6. Alright, we have already activated. I need to simply advertise network. Okay, so let me try to ping again. You see, 2222 is pinging, and here show IPv6, show BGP, IPv6, unicast summary. You see that there is a neighbor already up for last 1 minute and 15 seconds. And now if I try to ping 2000::2 with a source of 2222::2222, repeat 1000 times, the ping happens. See, both IPv4 and IPv6 communication happens simultaneously. Behind is IPv6 ping, sorry, IPv4 ping. From R1 we have IPv6. So both the routers respond. IPv4 is responding for, sorry, router 2 is responding for IPv4 request. Router 1 is responding for IPv4 request because we ping using IPv4 address from R2. From R1 we pinged using IPv6 address, so router 2 is responding. I don't know why it is rolling too much today. What I was saying is when I ping my IPv6 address from here, R2 responds. At the same time, R2 also pings IPv4 address and the R1 responds. Yep, this is 10,000 times, that's why it takes time. So without any downtime, we are able to migrate from, not a complete migration, we are able to have both IPv4 and IPv6. So once you find every customer, all your downstream ISPs and upstream ISPs, if you are ISPs of ISP like GLab, then you need to wait for everyone to migrate to IPv6, then you can remove IPv4 slowly out. Now here is another scenario where we are going to have IPv4 only network. This R2 is going to be internet for us, and I'll remove this IPv6 completely from, or let's do one thing, we'll keep it as a separate topology. Let us not disturb this topology. I'll do it in the next topology, another lab. So this lab was a simple lab running two BGPs, one for IPv4 and IPv6. Likewise, you can run RIP or EIGRP or OSPF. Enabling IPv6 and enabling BGP or any protocol will not disturb IPv4 that is running already. So let me go to another topology to do second lab. So this is also dual stack on the provider side. The provider has got, not the provider side, on the customer side. The customer has got 3 sites, site 1, 2, and 3. Actually speaking, the customer has migrated to IPv6. But the ISP is not supporting IPv6 like GLAB network, which has not started IPv6 support. But a customer is asking for IPv6 today. So GLAB wants to migrate to IPv6. The first step I already showed you. That's the best migration strategy. Now this one, in case if customer needs IPv6 communication, but provider is not ready to migrate, in such scenario, you can go with the 6 to 4 tunnel. What does it mean? ISP is in 4, you see, 100, 100, 102, 100, 101. Let's say this is the IP address ISP has given you. And 3.3.3. All right, now this is ISP given IP address. ISP will also provide you reachability. So using that reachability, you will be pinging, right? So that is what I'm going to simulate now. First, I'll start with ISP. ISP has got only IPv4 address. You will see me typing only IPv4 address. Interface G3/0. No shit. IP address 1111.2. Sorry. 1.1.1.1.2. 255.255.255.0. I want to run OSPF to provide reachability between R1, R2, and R3, so I say IP OSPF area 0. Interface G4/0. IP address is 2.2.2.2. 2.2.2.22. I'll give 22. Because 2 I have already said in the customer side. 255.255.250. And then IP OSPF 1 area 0. Interface G5/0. IP address is 3.3.3.33. All right, so we got IPv4 address with OSPF show IP interface, show IP OSPF interface brief. I have OSPF running on all these 3. Now let us move on to the customer side. See, you need to understand the scenario very well. What is that? ISP is not ready to give you IPv6 service. That's the scenario. So you're free to use any IPv6 address now. You need not to stick on to any rules now. You can use any IPv6 address that you like. But for 6 to 4 tunnel, I'll show you what sort of address that you should use. What I'm coming to say is ISP is not going to be behind you saying you cannot use this. You're free to use IPv6 address, anything that you like. And for this method 6 to 4 tunnel, I'll show you what sort of address, IPv6 address you need. Anyway, before that, we need IPv4 reachability, interface loopback. I don't want any loopback. Interface G3/0, IP address 1.1.1.255.0, IP OSPF 180. Now let us move on to router 2. Interface G3/0. Now R3. Alright, so this 3333 and all, who gave? ISP has given us. This is a public IP address. Alright, now I'm expecting reachability between 1, 2, and 3, which is what the service provider guarantees. You say ping 101.1, I should ping. Ping 2.2.2.2, I should ping. We got reachability. ISP will provide you only this much. Now, the story begins. ISP has provided you what? IPv4 reachability. This is enough for us to do IPv6 between the sites. I want to use IPv6 in my sites. Now, what address I should use? We are trying to learn 6 to 4 tunnel. We are trying to have 6 to 4 tunnel, and the topology that we have currently is this. You see, now we need to choose an IP address, IPv6 address for the site 1. For the site 1, we need to choose an IP address that will have this address embedded. Yeah, that's the condition. You need to have the first 32-bit of your IPv6, not first 32. The second and the third hectate of your IPv6 to have this. For example, if your IPv6 starts with 2000, the second hexadate and third hexadate, here 16-bit, here 16-bit should be 1.1.1.1. Means you need to embed your IPv4 address in this and in this place. Likewise, here for router 3 site, you will have 2000 and embedding 3.3 IPv4 address colon 3.3 IPv4 address. And the fourth hex state can be any subnet. If you want to have multiple subnets, you need to begin with this and maybe 01 for the first subnet, 02 for the second subnet, the same thing. You know, that is how the entire organization will have this one as common. This one will vary department to department, multiple subnets. All right, I'm going to do this and show you. Now I need to convert this one into binary. Sorry, yeah. I need to convert this into binary so that I can embed it into the IPv6 address, which is hexa. Listen, wonder, how can we write 0000001? This is what 1.1.1.1 means, right? 32-bit. Now, if I need to write in hexa for the 40, I have to put 10 because 4 bit of binary is 1 bit of hexa. Over colon again 0101. Anyway, this leading 0 has got no value, so 11 colon, sorry, this 0 has got value, 101 colon 101. So in this site, we the subnet that we supposed to use is 101 colon 101 colon slash 48. So you got 48. Up to 64 you can have, no? So you can do multiple subnets. Listen, this is the network. These are the bits that I must match. But I can have subnets like this. 1 colon. This is going to be slash 64. And then again, I can have another department with 2, 3. You see, this is the network that you should use. And I'll give for the physical interface G3/0 this address. Maybe I'll put colon 1 here. And for other subnets, meaning for other departments, for example, Lubeck 0, I'll give 2.1, Lubeck 2. So Lubecks are like our departments. Instead of having a physical network, we are having a virtual LAN there. That's it. This is what the address schema that you should use. Now let's convert 2222 into hexa and repeat this. 222. So here is going to be 2, here is going to be 2, here is going to be now 10, right? 10, 10, 10. That is what 2.2.2. Anyhow, no problem. It is going to be the same answer, 0202 colon 0202. So this is going to be 202 colon 202. And likewise for 3, if I say this is going to be 111111, that's what 3 means. Then I'll have what 03030303, which means 303 colon 303. Yeah. Now we understood what to use in the second and third hectate of the remote sites. Remote sites, wherever I have 101, I have to put 202 colon 202. Yep. Likewise, this department is going to have 303 colon 303. Right? Now, let us apply this. Apply it, and then we will start our 6 to 4 tunnel configuration. Going to the consoles of our WAN first. Interface G3/0 IPv6 address 2000 colon 101 colon 101 colon 1. Sorry, the subnet 1 colon 1/64. And interface loopback 0 will have 2 as a subnet. Interface loopback 1 will have 3 as a subnet. Now, the set is ready. Let us go to the other side. Router 2, interface G3/0, IPv6 address 2000 colon 202 colon 202 colon sorry, the subnet 1 colon 2/64. Interface loopback 0, I put subnet 2 and I put subnet for loopback 1. You see, you can also have 0th subnet. I have not used it because we have plenty of IP address, plenty of subnets. If you want to use 0th subnet, you can use it. Network is 48. The derived network is 48. We are making it a 64. So those 0 bits will be considered as a 0th subnet. Now what is left is we need to enable the tunnel. Listen, it's very simple. Interface tunnel 0. See, for the tunnel also we need IP address. Mistakenly, I have given the tunnel IP address to the physical interface. So I'm going to remove that. Sorry. I'm going to remove from interface G3/0. I'm going to remove this IP address. I want to give that to the tunnel interface. This is the one. I have to remove like this. and then interface channel 0. I'll put this IP address here. Okay, on the WAN facing interface, don't put any IPv6 address. That's a mistake I did. Now what is next is tunnel source. Tunnel source is G3/0 and no tunnel destination. Listen carefully. I'm saying no tunnel destination, meaning I don't know the destination. Destination need to be derived by itself. See, if I'm pinging these addresses, the tunnel destination will be router 1. If I'm pinging these addresses from R2, the tunnel destination will be 3. So my tunnel destination will keep changing. I don't know the destination. I cannot give any destination. It needs to be derived based on the ping that I make. Listen carefully. When I ping, what do I will put ping? I'll say if I'm pinging R3 is Lubeck, what I'll say ping 2000 colon 303, right? Colon 2 colon 1. This is what I'll do. So immediately from this ping that I'm making, it will know the IPv4 destination. Look at this, the secret. From the ping address that you use, the router itself will know that I need to deliver the packet to this IPv4 address 3.3.3.3. Is it right? Yes, it is. That's why we embedded IPv4 address in it. Okay, anyway, I'm not going to ping now. We have a few more configurations to do. Tunnel mode IPv6 IP64 tunnel. That's it. This is the secret. This is the algorithm. Now I'm going to repeat this on all other routers, then I'll show you pinging. Remember, on the internet we don't have any IPv6. Okay, now I'm going to R1. Before interface G3/0, I have to remove the IP address and put that IP address on the tunnel interface. Interface channel 0, no shit. And then I'll put this IPv6 address, which I removed from there. Tunnel source is G3/0. Tunnel destination is unknown, so I put no tunnel destination. And then tunnel mode is IPv6 IP64 tunnel. That's all. Now one more router will ping. Interface G3/0. I have to remove the IPv6. Oh, we don't have any IPv6 configured. No problem. Good. I don't know how I missed it. Show IPv6 interface brief. Is that true? Yes. I don't have. What have I missed it? Okay, in R1, show IPv6 interface brief. I have. What about R2? Show IPv6 interface brief. Good. So in R3, instead of 202, we need to put 302. So what I'll do is I'll just copy this from the running configuration, show RAN interface. Okay, forget about it. I'll do it manually. R3 here. Interface. So see, this is not G3/0, it is tunnel. Need to correct it everywhere. and this will be 22. I think here we gave 33 or whatever. No problem. That is not a matter here. Now, moving on to this interface tunnel 0. Tunnel source is G3/0. No tunnel destination. Tunnel mode is IPv6 IP64 tunnel. Tunnel IPv6 address is 2000 colon 303 colon 303 colon 1 colon 1 slash 64. Interface loopback addresses, just put 2 here. And interface loopback 1 is put 3 here. That's all. Now you will see wonders. See, in the middle on ISP router, no IPv6 address. Not even IPv6 unicast routing command enabled. I can ping from here. Look at this. Ping 2000 colon 101 colon 101 colon 1 colon 1. Oh, you know, one more thing you need to do. You need to first tell that whenever I ping from IPv6, it should use the tunnel. Only when it tries to use the tunnel, that 6 to 4 conversion will happen. So, in all the router, we have to say IPv6 route. If any address starting with 2000 colon 1, not 10, just colon slash 16. If any address starting with 2000, send it via tunnel 0. See, this is pushing the traffic via the tunnel. Very important part. Do it on R1 and R2. Yep. Now let us ping 2000 colon 101 colon 101 colon 1 subnet colon 1. Look at this. Look at this. Let me sniff the packet and show you what really made this ping happen. So I'm going to do the ping one more time. Look at this. You see, IPv6 original header and IPv4 header on the top. And you see the destination is automatically derived from the destination address of IPv6. The IPv4 destination is derived from IPv6 destination. Say I'm going to ping again. Ping 2000. This time I'm going to ping 303 colon 303 colon 1 colon 1. Now you see the destination is 3333, derived automatically from the embedded IPv4 address. This is ICMP version 6 protocol. ICMP version 6. So you can have double layer 3 header. One is layer 3 version 6 header and version 4 header. Ask me question. Please. Do you have any question? I think you are in mute.